Okay, we have one last problem here with this function. This time we are going to be doing midpoints of the interval. And so we still have a starting point of 0 ending at 4. Okay, so we do have a 4 minus 0 divided by the number of rectangles, which is 4. So we have an increment of 1. So if you think about this for a moment, we're starting at 0 and we're going to 1, and then we're going to go to 2, 3, and 4. However, this time we're not using any of these numbers because we're not using the left sides or the right sides. We're simply going right in the midpoints, right, of each interval. So in this case, we're going to use 1 half, we're going to use 3 halves, 5 halves, and 7 halves. So those are the 4 values that we're going to be using in our calculation. Now our calculation does have a common width of 1, which makes it nice and simple. So we have a 1 on the outside, and then again, in this case we just have square root of a half plus square root of 3 halves plus the square root of 5 halves and the square root of 7 halves. And then just like before, we can also then find, oops, not 5/7, 5 halves, and finally plus the square root of 7 halves. Okay, and then we need an approximation for this. Okay, and our approximation, we will say, is approximately equal to 5.383 or 384 if we rounded. So make sure you go out 3 decimal places. This answer most likely is probably the closest to the exact answer. Hey, let's find that answer, since I have a captive audience here. So let's do that. So we're looking for the value of 0 to 4 of the square root of x dx. This is a half power polynomial. So we do get 2/3 x to the 3 halves power. And we're going to evaluate this from 0 to 4. Let's put our 4 in first. So we get 2/3. And then the square root of 4 is 2, and 2 cubed is 8. So I get 16/3 as my exact answer, because we put 0 in, we subtract 0. So 16/3, or 5 1/3, or I guess is a decimal, 5.3 repeating. So it looks like, again, this was the better of the